Hello dear student, welcome to my class. We already discussed different cases of lens if object placed different position and how to calculate image in that situation. Clear? Now we are going to discuss about a most important concept that is known as optical instrument. So what is optical instrument? It is the type of instrument which is able to see distinct and very clear image and magnified image of an object. If we place object very close to the optical lens or very close to the lens or far away from the lens. Clear? That type of instrument is known as optical instrument, and this optical instrument is of two types. First one microscope and second one telescope. So what is microscope? If there is a object and that object is very close to the eyepiece or very close to the magnifying lens, at that time we have to use microscope. If object situated at infinite distance, now we have to see this object image clearly of the object which situated infinite. That time we will use the instrument or optical instrument is known as telescope. So first we will discuss about what is microscope. Clear? So first optical instrument is known as microscope. And depending on the position of an object and depending on the size of an object, this microscope also divided by two parts. First one simple microscope and second one compound microscope. So first we will discuss here simple microscope. So first we will discuss that is simple microscope. Clear? So for your council examination it may ask for 3 mark question. What is simple microscope and find magnifying power of its simple microscope. Clear? So first before going to discuss about simple microscope, we have to know some basic idea about optical instrument or eyepiece. You already know, suppose there is a eyepiece like this. This is the diagram of eyepiece, and here this is known as iris or iris, and this muscles is known as ciliary muscles, and there is a lens, and this lens which is known as biconvex lens or convex lens simply. Clear? And there is a inner layer is known as retina, and due to the compression and expansion of these ciliary muscles, we can able to change the focus point and we can able to change the radius of curvature of this lens. That means we can able to change the power of this lens. So this is lens, this is eyepiece like this. Clear? Okay. Suppose this is principal axis. Now there is a object, and this object which lying on the principal axis just away from the eyepiece, and the ray and traveling this direction, this is optical center. Clear? And another ray which travel this direction which meet at this point. So this angle, suppose this angle is theta naught. So what is theta naught? And theta naught here, this object subtended by an angle are the eyepiece. Clear? This object subtended by an angle at eyepiece, this theta naught is known as this angle. Now or this theta naught is also known as visible angle. Visible angle. We already know what is distinct vision, least distance of distinct vision. That means least distance of distinct vision means we able to see the minimum distance for normal eye, and that time we use the distinct vision concept. So if if this object is placed at a distance least distance of distinct vision from eyepiece, then it is denoted by D, and D is here least distance of distinct vision. So least distance of distinct vision means, suppose there is two letter least and distance, then there is this distance, suppose 1 meter, and which is clearly visible to me. If I taking my eyesight towards the least distance, or if distance decrease, then this least distance is blurring condition and gradually it blurs. That means after a particular time, this two word which we cannot distinct means we cannot separate. So that time we cannot use least distance of distinct vision, means we can able to see these two words and there is separation between them, and that normal distance between from eye to the object is known as least distance of distinct vision, and it is denoted by D. Clear? If this is a object and this distance from my eye is least distance of distinct vision, if we take this object from least distance is this object from closer, that means this object is not least distance of distinct vision. At that time we cannot see this object, because this object its image now blurring condition. So if we want to see clear image of that object, then object should be placed at least distance of distinct vision. We already know for normal eye the least distance or mean least distance of distinct vision which is equal to 25 centimeter for normal human being or normal eye. Clear? For old age people, the least distance of distinct vision is about, that is 40 centimeter. For child, the least distance of distinct vision which is equal to 15 centimeter. So if we compare overall condition, then it lies least distance of distinct vision lies between 15 centimeter to, that is 40 centimeter. But its mean, the average mean which is equal to 25 centimeter is, we already know, that is least distance of distinct vision. And at that time this if you object placed at 25 centimeter, it is easy to visible. Then if we suppose there is a object which is 25 centimeter and it is easy to visible. Clear? If this object is not least distance of distinct vision, or if this object is very close, suppose this distance is not 25 centimeter and this distance is suppose 10 centimeter, then at that time we have to compress my ciliary muscles, because if we compress the ciliary muscle, then its focal length and radius of curvature, this radius of curvature decrease, because due to expansion and compression of these ciliary muscles we able to see the object. So if object is just 25 centimeter, so at that time the ciliary muscles is normal case and it is easy to visible. If the distance is very close to us, then at that time we have to compress the ciliary muscles, we have to compress the eye in this way. Clear? To see the object. If there is an object which is infinite distance, then at that time the ciliary muscle is relaxed in this way. Clear? So these are the position of least distance of distinct vision. And again there is a condition so that we can able to see the image of an object, and this angle should not be less than here theta naught, the angle or vision angle should not be less than 1 minute. So you know the conversion of degree into minute, that means 1 degree which is equal to 60 minute, and 1 minute and this can be right, that is 60 symbol minute. So 1 minute which is equal to 1 by 60 degree. 1 by 60 degree. If this theta, and for least distance of distinct vision or distinct vision, theta naught should not be, if theta naught is less than 1 minute, then we are not able to see, not able to see the object. If theta not greater than 1 degree, then able to see, able to see. So for distinct vision you have to remember two things. The distance should be least distance of distinct vision, which is 25 centimeter, and the angle subtended by eyepiece with an object, and this vision angle should be greater than 1 degree. Clear? Suppose there is a object like this, there is a object here. If we observe from this point, if we observe this point, then this object make an angle. Suppose this angle is theta 1 and this distance is suppose any distance, so it is d1. If we again observe here this angle, then at that time this is object which is at this position, but now this distance is greater as compared to the first distance, which is d2, and again now this is theta 2. If we take the observer here or eyepiece here, at that time this angle is now again decreased theta t. That means here theta 3, theta 2 and theta 1. Clear? And this is final theta 3. And we able to see the image of an object such that the angle or vision angle should not be less than 1 degree. That means if this angle is now 1 degree or more than 1 degree, then we able to see this image for naked eye. Clear? And if angle is suppose this theta 3 is less than 1 degree, we cannot able to see this image of this object. So at that time we need to use a convex lens, or we need to use a magnifying lens, that is known as simple microscope. Clear? The object which cannot be seen with a naked eye, at that time we have to use a simple microscope, or that microscope is known as magnifying microscope. Why? Because if we not able to see our naked eye this object, then we have to use a lens here which magnifying this object, and now we able to clear, now we able to see the image of an object clearly and magnified image. Clear? So that's why we use simple microscope and compound microscope. Now we will go for simple microscope, construction, working and magnifying power of simple microscope. So first we will discuss about simple microscope and its construction. Suppose we have a lens here, and this simple microscope also known as magnifying glass. Magnifying glass, there is a convex lens, and this is optical center, suppose C, and this is principal axis which pass through the optical center. This point, suppose the lens is here L. Clear? And there is two focus points, suppose this is focus F and here focus F. This focus is known as second focus and this focus is first focus. Suppose there is an object which is lying in between focus and optical center here, then we get a image. This is object AB, and the ray which is parallel to principal axis, after refraction through lens, it passed through the focus point like this, and its backward extended ray like this. Clear? And we already know the ray which passing through optical center, it travels undeviatedly like this. Clear? So if we draw here the backward rays, this is simple microscope. Then these two rays or backward extended rays appears to meet this point, and finally we get a image. This is final image, which is equal to A dash and this point B dash, which is suppose at a least distance of distinct vision, which V is nearly equal to D. Clear? And this distance is known as object distance, that is U. This is optical center. Clear? And this image, you already know about this image, and this is second ray which traveling this direction, and these two rays are appear to meet back side of the object. So we get a final image. This image, the nature of image here, which is virtual, and here the image, nature of image, that is virtual, erect and magnified image. Clear? So if we observe here, suppose there is a eyepiece here which is very close to the lens. This very close to the lens, this is eyepiece here. If we observe, then the image of this object which will get like, that is A dash and this point which is equal to B dash. Clear? And that image which is magnified, erect means same side of the object, and again virtual. Clear? Okay. Now we will discuss the magnifying power of this lens. So magnifying power is important, that is magnifying power of simple microscope, and it is represented by capital M, because small m is represented by that linear magnification. So here we will use the magnifying power. So what is magnifying power? Magnifying power means it is the ratio of angle subtended by an image at aided eye with a least distance of distinct vision to the angle subtended by this object at unaided eye at the least distance of distinct vision. Suppose if we take this angle here, suppose this angle is image here. So if we take this angle, suppose beta. Clear? And first we have to know, or first we have to observe one thing here to calculate magnifying power. This is object. Now we have to place object and image at the same position to calculation of magnifying power. That means this is object AB. So first we have to take this object AB, now place here, then here A dash. Now this point, suppose here the object now, and this point we can write, that is B dash. This object now place here, that means this object and image now at a distance of distinct vision which is equal to B. And at that time if this object is placed here, then we have to draw a angle from this eyepiece, because this eye is very close to the lens. So this angle is known as eye lens. So if you draw here a angle like this, and this angle is known as alpha, and this angle is known as beta, and beta is here angle subtended by an image at eyepiece. And what is alpha? Alpha is angle subtended by object. Clear? Aided eye and unaided eye we will discuss here. So magnifying power, it is the ratio of angle subtended by an image at eye at least distance of distinct vision divided by angle subtended by object at I, and this eyepiece is known as, that is known as aided eye. Aided eye, we can write here aided eye, at eye, or we can write at unaided eye at a least distance of distinct vision. So what is the meaning of aided eye? And there is another term which is unaided eye. Unaided eye means this is known as naked eye. Naked eye means without lens. This is the angle subtended by object without lens. That means suppose there is a this is eyepiece here, and this is principal axis, and here this is ciliary muscles, and there is a lens, biconvex lens here, clear, and this lens ray which pass through the principal axis like this point, and there is a object, clear, this object, and this angle is known as alpha, and this eye is known as unaided eye without this lens. Clear? Aided eye means we have to use a lens. At that time we able to see the image of an object, and at that time the angle subtended by image, that is known as beta. So this angle is known as aided eye angle. Clear? So at that time we can write here angle subtended by an image at eye, angle subtended by an image aided eye at least distance of distinct vision. This is image, so its angle subtended by eye, because this eye is very close to lens, and this length, and sorry, this angle is known as angle subtended by image. So you can write here this angle is beta divided by angle subtended by an object, and this is the object, and this is the object also here, and this object which is situated at a least distance now. So this distance is d, and this is object AB, and this angle is known as alpha, which is unaided eye means naked eye. Clear? So at that time we use here alpha, but this angle is very small. Alpha and beta are very small, so at that time we can write beta can be write for very small angle, very small angle at eyepiece. So we can use alpha which is nearly equal to, that is tan alpha, and beta nearly equal to, that is tan beta. If we replace this value here, then we can write that is tan beta divided by tan alpha, which is equal to magnifying power of simple microscope. Clear? Now we have to find this tan alpha and tan beta. Now look at the triangle here. So first tan beta. In triangle there is a right angle triangle. This angle is beta because actually this image is not at the distinct vision, but here we place this image by adjusting the lens which is at a distance of least vision, but this image may form at far distance. So at that time we have to use this length, that is the angle A, B and C. In this triangle we can use in triangle A, B, C, or you can use also ADS, BDS, C triangle. This triangle and this triangle. This angle is common angle, so you can write ABC triangle here. That is tan beta equal to perpendicular upon base. Here perpendicular AB. So you can write AB divided by base, which is equal to AC. Again in right angle triangle, now we have to find the value of tan alpha, and this angle is alpha, and if this angle is base angle and this is base perpendicular and this is hypotenuse, at that time we can write A dash B double dash in triangle A dash B double dash C, A dash B double dash C, and here C is common angle, so we can write here that is tan alpha equal to perpendicular upon base, and you can write a dash b double dash divided by a dash c as ab which is equal to a dash and b double dash here. AB which is equal to a dash b double dash here. Then this term we can write tan alpha which is equal to a double dash b double dash. We can write here AB by a dash c. This is second relation for tan alpha and this is first relation for tan beta. Now magnification can be write m equal to tan beta which is here, that is AB by AC into divide, then this term will be reverse, a dash c divided by AB and AB cancel, the remaining part that is a dash c divided by AC. This is magnification. By using sign convention, sign convention is important. So here the ray which traveling this direction means right to left direction, this is the direction of incident ray. So all the distance are measured along the direction it taken to be positive, but opposite direction it taken to be negative. But we have to find the value of a dash c and AC here. So a dash c, this distance, but distance always measured from optical center to that point. So this distance we can write here, that is minus d. Clear? Because this is the incident ray direction. Next AC means this distance which is equal to minus u. If we use this value here, m equal to a dash, that is minus d by minus u, minus cancel, and here that is d by u, and magnification of simple microscope can be write, that is d by u. This is general formula. Clear? Okay, if this is general formula, then we can use for maximum magnifying or maximum magnification. We can say, suppose this is maximum magnification, and at that time for maximum magnification means we get the maximum visible of an object, or we get the image which is clearly visible, and we have to find that object as in distance from the eye lens, and we already have a lens formula, that is 1 by f equal to 1 by v minus 1 by u. Clear? Okay, but initially this object u which is situated this distance, clear, we have to adjust this lens in such a way, and at that time the image is placed at a least distance of distinct vision. Suppose here object is u now and the image is at a distance v, but you already know for convex lens the focal length is always positive, for concave lens the focal length is negative here. So if you use sign convention this case, then by using sign convention we can write here, that is 1 by f which is equal to positive equal to 1 by v, and v is here least distance of distinct vision and which is negative because this is the initial ray. So we can write here, that is minus d. Clear? V which is equal to minus d, then minus 1 by u, and u is here also we have to measure this distance minus u, and again we can write here minus u, and 1 by f equal to, that is minus 1 by d plus 1 by u. Clear? This is the relation. So if we solve this 1 by f equal to minus 1 by d, we can write here, that is 1 by f equal to minus 1 by d plus 1 by u. But we have a magnifying power, that is m equal to, which is equal to d by u. This is general expression, and we have to solve this relation in terms of this format. So here 1 by d, if you take this side, then this term will be here, that is positive. If you take this side, it will be positive. Then we can write 1 by d plus 1 by d plus 1 by f which is equal to 1 by u. Now multiplying on both side by d, if you multiply both side by d, then this term will be, that is d by d plus d by f which is equal to d by u. Clear? Now use this value here in this equation. Now the magnifying power and this magnification is known as maximum magnification. Maximum magnification which is equal to d by u, and the value of d by u, that is d by u, which is equal to here d by d, which is equal to 1 and 1 plus d by f. So magnification or maximum magnification in case of simple microscope at the time, that is 1 plus d by f. You have to remember this relation. Clear? Okay. If we increase or decrease this focal length, then magnification we can increase or decrease. If this focal length decrease, then magnification increase, and focal length increase means magnification decrease. This is maximum magnification in case of a simple microscope. So what is minimum magnification? Now this minimum magnification is also known as a normal magnification. Clear? So for minimum magnification or normal magnification, normal adjustment, it is also known as normal adjustment. Normal adjustment or minimum magnification. So in this case, suppose this is object. At that time the object which is placed in between focus and optical center. Clear? Focus and optical center. So we get a virtual image which is behind the object. If we place this object at focus point, then what is the position of an image? We already know. If there is a lens and this is focus point, if we object place at the focus this point, then the ray which passing parallel after refraction to travel this direction, in this direction, and if we take another ray which incident at optical center, it travel parallel direction. That means this is parallel line and this is parallel, they never intersect each other, and the image formed which is at infinite distance. At that time we have to use v which is equal to minus infinite, because this is infinite distance object. But object, now object here u which is equal to f. Now object situated at focus, but image which we get at infinite. Clear? At that time we get a normal adjustment or a minimum magnification. Clear? So in this case there we have to use the formula that is the formula. What is that formula? Here we already have formula, that is magnification m equal to, that is d by u. This is the initial case. Clear? Or this is general case. So if we use here the magnification m which is equal to d by, and u is here f. We already used the sign convention for u, so we can directly write that is d by f is magnification. Clear? In case of normal adjustment, so we get minimum magnification. We observe here, if there is eyepiece, then object which is at infinite distance. Clear? If we want to change the position of an object, then minimum magnification means this angle should be minimum, this angle should be minimum. Clear? Here angle which is beta, and see this angle is maximum as compared to this angle, because this object is just in between focus and optical center. So this angle is large, and magnification, this magnification depend on this angle. Now here this angle is, object is placed at focus, so this angle is now less than that angle. If you want to again decrease this angle for minimum magnification, suppose if we place object here, then what is the image or what is the position of an image in this case? We already know, if object is placed in between f and 2f, then image is formed in this side. Sorry, this image is formed in this side, and which is downward direction. This is real image formed. This image will be real if object placed just beyond or beyond the focus point, then image is real and it is inverted image. Clear? And magnified also. So in this case, but we have to need a virtual image for magnifying power. So this is the minimum case where we have to place the object which is at a distance of focus point, clear, or focal length. So at that time we get a minimum magnification which is m equal to d by f. This is all about magnification in case of simple microscope, clear. And the most important uses of simple microscope, it is used watchmaker to see the teeny particle or to see the teeny part of an watch. And because this magnifying glass or simple microscope which give a large image and clear image, so watchmaker it is used. And then it is used also jewelry shop to see clear image. And next it is used for science laboratory to read. Basically it is used in physics lab also, science laboratory to read, that is Vernier division, clear. In science laboratory it is used to read the Vernier division, that is small division. Suppose there is 1 centimeter gap, then in between 1 centimeter there is number of line here, so it is difficult to count with naked eye. At that time we will use a simple microscope for magnification, clear. So these are the important uses. Or another important uses, suppose there is a page which is printed with like this very small letter and which is not visible to our distinct vision. So here if we use a lens, and the lens is known as simple microscope of magnifying glass, and this printed line are visible, clearly visible to us, at that time we use a simple microscope, or that is magnifying glass. These are the uses and magnification and position of object and position of image. How to calculate magnification for maximum magnification and minimum magnification, clear. You have to remember one by one step. This concept may ask in your council examination, clear. Okay, thank you.